me. So thank you for joining me. I hope you've enjoyed all the content today. It's fantastic. I've learned a lot. I liked the challenge in the previous session related to organizing your projects. Today, I'm going to talk to you about measuring DevOps success with pipeline analytics. And if I have one job today, is in the next 25 minutes or so to convince you that your software delivery chain is the application of applications. So it is as important as the applications that it delivers, and it deserves a lot of attention and strategy in terms of creating visibility for it. Now, I suspect I'm not going to have to really try that hard to convince you. We are all Hashi fans, so it means that we think in terms of automation, we think in terms of scripting. By the way, if you're wondering what's behind me here, it's my German Shepherd. She decided to show up as well. We're all used to automation, coding everything. However, one of the things that I've noticed with a lot of organizations is that they think in terms of automation for the purpose of velocity, going faster. But I've also seen that velocity can come back and bite you for a lot of enterprises. And it happens when you don't create visibility. So my job is to kind of re-emphasize the importance of visibility across your entire software delivery chain, not just some aspects of it, or not just your applications and production. Because if you think about your software delivery chain as an application, what that means is that it has users, it has customers, then you need to treat it like an application, just like your application in production. You need to make sure that it's operable, it's secureable, and it's measurable. So yes, I am a bad coder turned advocate. What does that mean? Well, I ended my software development career about 12 years ago, and I'm almost embarrassed to say I was a .NET developer specializing in, yes, SharePoint. And if that makes you cringe, I'm sorry, it made me cringe as well. That's why I gave it up. Not here to talk about myself, but if you're interested in connecting, learning about my podcast, scan that QR code there and it'll get you to my informations. My job is a DevOps and developer relations advocate. What that means is that externally, I speak at events like this and I talk about all the things that I'm really passionate about, which is getting companies to embrace modern development practices. Internally, I help Splunk align those with technology. So let's start first. What do we see in most organizations? What does it mean not to treat your delivery chain as a product? This is very common. What you see essentially is a lot of visibility silos. Visibility silos are where individual teams are really good at creating visibility for their particular domain, but they're not good at sharing that information with other teams. And they're not good at correlating that data, those dashboards, across teams. Now, one artifact or one reason for this is that developers, they follow the path of least resistance like everybody. They will adopt the tools that make sense for them. And oftentimes they're adopting tooling to solve a specific problem at a very specific time versus looking at it from a holistic and strategic perspective. Yes, I know we use this term DevOps as a thing that means that we all get along, right? We're all friends. It's not really about that. As we move faster in application development life cycles, we are all more accountable for the work that we do. And being accountable means that we need to waste less time, if you've heard the term shaving the yak, less time trying to reconcile information across teams and trying to build the framework just to operate. And so these silos actually come at a tremendous cost. And the greatest silos are the ones between the developers and what happens in production. But that's been changing with the SRE, with the rise of the SRE role, where you have an embedded partner as a part of your operations and development teams. So what people in organizations and engineering teams should really strive towards is this idea of code to cloud visibility. The fact that you should be able to trace, and I don't mean traces as in traces and spans, I mean you should be able to connect the dots from the point that a feature is defined in your backlog to the point that that feature is running in production, even if it's a feature flag. And you should know the relationship between that feature and what happens in production. Now, this is not just about being better at supporting your applications. This is also making your lives easier when it comes to communicating to the business. We all get a paycheck. We are building our applications because we have users. And those users at some point down the chain are the ones who give us money. And so correlating your work with the business bottom line and delivering value is important for everybody. It's important for you individually to support your career. It's important for the organization and your ability of your team to get the support and tooling that they need to do their jobs. So one thing that organizations tend to be really good at is monitoring our applications in production, full stack monitoring, creating visibility from the infrastructure in the data center all the way up to the front end with real user monitoring or DEM. But what they tend to forget is all of the things that happen prior to getting to production. So if depth is monitoring, breadth is pipeline analytics. And I think I've already made it clear why pipeline analytics. And this term, I think, is relatively standard for what I'm talking about, but you may have heard the term value stream. That relates more to business. But really, why we are doing this is that, first of all, if your software delivery chain is down or has a gap in it, then you're only as good as your weakest link. No code ships if your software delivery chain is down. And that includes Hashy tools. If Vault is down, that's a problem. Terraform's down, that's a problem. Not only that, and all of recent news will attest to this. Last week, there was a very popular article about repositories, artifact repositories, and the difference between a private repo and a public repo, and pulling down artifacts from a public repo that have vulnerabilities in them. So this is a very real risk where your software delivery chain is a part of your enterprise's attack surface. Hate to say it, it's already been brought up a lot. I'm sure you've heard it more than 3 times today, but the SolarWinds attack was all an artifact of the fact that if people get access to your software delivery chain, especially your secrets, and especially your secrets management process and tooling, then it does impact the vulnerabilities of your application in production. So it's impacting your security surface. As I said, it impacts the ability to communicate with other teams. Developers are speaking a different language than the operations teams. And the fact that they're speaking the different language when they need to collaborate, they have to reconcile that. And that is a huge waste of time. It's context switching. It's not time anybody wants to actually spend. But also the security teams. All the security teams tend to want to know is that the proper tools are in place to make sure that you are building more secure applications and your delivery chain is secure. It's hard to measure business value. And ultimately, it's also pipeline analytics supports reducing technical debt in 2 key ways. It helps you measure current technical debt, and it helps you anticipate future technical debt by understanding what is going on in your delivery chain and ways to optimize. And if you embrace this idea of shift left, pipeline analytics is mandatory. So at Splunk, we have a tools productivity team who is responsible for implementing pipeline analytics. And there's some great demo videos out there showing this. But we have identified many areas to reduce build times, to increase efficiency, to spot potential holes in our delivery chain and our automation, and have used that to improve our delivery chain processes. So how do you do it? It's actually really straightforward. I know you've been seeing a lot of great sessions that are super technical and complex and a lot of code. This is not really that. That's the good news. For some of us, we want it to be more technical. But so first of all, you got to get logs and metrics from your tooling. So this could be logs from Terraform. It could be logs from Vault. Maybe it's coming over web via webhooks, via your SaaS-based repository tool. Whatever it is, you need to get the data. Chances are most of the platforms you use have that data. I'll admit that if it's via webhooks, it's a little bit more difficult because getting historical data and being able to establish trends is a little bit more difficult via webhooks than it is with logs. The next thing is you need to correlate the data across tools and across teams. One major tip here, if you are going to embrace pipeline analytics, make sure that your ticket numbers from whatever system you're using, it could be Jira, are a part of your commits. Because if it's not, it's very difficult to correlate tickets with commits and builds and deployments. And then finally, you set up a strategy to observe this data, which implies dashboards. You build dashboards. Typically, you have team level dashboards, which are relevant to everybody. Or I'm sorry, global dashboards, which are relevant to everybody. And then you'll have team level dashboards, which tend to be relevant to individual application teams and service owners. There are three primary use cases of pipeline analytics. First is monitoring, and I'm going to talk about each of these. Second is auditing and compliance. And third is measurement. So starting with monitoring, this is the one that is the basis of the idea that if you own the delivery chain, then you have to make sure that it's up and running. You have to make sure that your Jenkins server is up and running, that you have access to your secrets and people are able to utilize those. This is a monitoring problem, and it actually ends up being exactly the same as you would treat other applications in production or potentially third-party tooling. I know our SRE team, the way they've set it up is that developers are responsible for their services, but all third-party tools are the responsibility of the SRE. So in this case, monitoring, leveraging pipeline analytics tends to be the job of the SRE or tends to be the job of the DevOps engineer. So this is all to meet your service level objectives to your developers to make sure that the delivery chain is as they would expect. It's your standard infrastructure metrics and maybe your red metrics, rate, error, duration, and your is it up or is it down? Fairly standard. The next one, I mean, if you're really crazy, then you might really enjoy auditing and compliance. For me personally, I'm not all that interested in it, but I am interested in not getting exploited. So part of audit and compliance is the idea that you know how your tooling and your tooling chain is being used, you know who is accessing it, and you can identify any sort of suspicious behavior. Because if somebody gets access to your repos and then starts putting in malicious code, well, that's going to get you in trouble, and we already know the ways in which it will. So the first purpose of audit and compliance is for just protecting your delivery chain. If you're in a large enterprise, it goes further than that. If you're in a large enterprise, you probably have an auditing team. That auditing team is responsible to make sure that the proper tools and processes are in place to have visibility into the organization being compliant with the various areas they need to. If it's in financial, you have all the financial compliance, healthcare, all the healthcare compliance. Usually what this means is that you have the data, you simply have an audit trail. But for a lot of organizations, they don't have this data for their delivery chain. And what happens when they get a request from this team, they have to stop everything and deliver the data. And it creates a lot of enemies and contention, and it's not fun. And this is actually one of the primary drivers for pipeline analytics. With pipeline analytics, at the drop of a hat, you can deliver this data to your compliance team in a format that makes sense to them and be able to reference the processes and tools you have in place to make sure that you are compliant. And this is going to relate to some very basic things: authorization denials, requests by IP address, requests by type, policy, etc. For example, policy, if you see a lot of root access going on, that's probably something you want to investigate. You see people trying to get access to your repos from IPs that are suspicious, that is something that you want to investigate. So there is a very real reason to invest a lot of energy up front to make sure that your visibility, your software delivery chain delivers on audit and compliance data. Now, this is the fun one. This is what most people get really excited about, which is, how do you measure the value of good in DevOps? Again, a lot of times we talk about DevOps from the perspective of we all get along and we get to go fast. But velocity is worthless if you can't measure the value of good. You can't say, well, now that we're going fast, we have delivered X more value to the organization. We have, over the last few years, we've been transitioning from this idea that we are delivering applications to the fact that we're all actually building, most of the time, we're building services. And we're not talking about, we certainly talk about commits and build numbers, but we don't really reference our products in terms of versions. And this is one of the reasons I like to think about the role SRE as actually being a service reliability engineer and not a site reliability engineer, because site implies monolithic and static. Because we are delivering services, it's a stream of consciousness to understand what is actually going on and how you know that you're doing well or not doing well in your processes. So this is where measuring the value of good comes in. And pipeline analytics is very often used by development organizations to set up specific metrics in order to determine that when you make new deployments, you're introducing more technical debt or less technical debt, how it's being adopted by your users. There's a various range of measuring these. So the first most important thing that the organization has to do is choose your measurement. And you don't want to underestimate this. I've seen a lot of organizations who are very successful in just having a single metric around velocity, number of commits per repo. I've seen organizations have tens of metrics, which they're successful with, but some aren't successful with. One example of this is a lot of teams will tend to gravitate towards this idea of having leaderboards. And sometimes leaderboards backfire in a big way with the development teams. It creates animosity, maybe unhealthy competition, maybe good competition. So understanding what you want to measure is important. Second, you need to make sure that you can measure it. So one of the key challenges I mentioned before is that your commits, every single commit, should have the ticket number associated, the feature ticket number or bug fixed ticket number associated with that commit. Because only then can you correlate what happens from your product backlog, all the way to what happens in production. Honestly, there's other ways to do it, but you make your life a lot easier if you invest this tiny little effort. So are you even able to deliver these metrics? Don't go down a path of creating metrics that are interesting to you without actually being able to measure it. So there was another metric that I totally forgot about. But this is very important to think of in advance. Now, there is some standards out there, and for better or for worse, there's something called the DORA metrics. If you're familiar with DORA, DORA came out of the DORA Institute, which was at some point acquired by Google, who published the annual DevOps State of DevOps report. Through their research, they identified some of the most common metrics used by engineering teams that should be a part of all software delivery processes. DORA is somewhat become a standard, but that's just by artifact of a popularity contest. There's many other metrics out there, and there's another framework called the Flow framework. The DORA metrics break down into 5 standard metrics, which, well, really 4 standard metrics, which are deployment frequency, how frequently you are releasing your services, pretty straightforward. Lead time to change, how long it takes from a feature to be defined to the point that that feature ends up in production. Change failure rate, when you make a change in production, how often does it go okay versus breaking? And time, the standard time to recover, time to restore. Something breaks, how long does it take you to fix it? But there are other metrics that I really like, and I would encourage anybody to consider. But before I talk about them, the best way to get to these metrics is by establishing a common information model. A common information model for pipeline analytics breaks down the standard data you are going to get by tool type. So if it's an orchestration tool, you're going to get a standard set of elements from every single orchestration tool. If it's a repository tool, you're going to get a standard set of elements for those repo tools. So some of the other metrics that I really like are work in progress. So this is just the bandwidth, or it's really your backlog, but it should establish from a sense of flow the amount of work that you can currently process through your delivery chain. One thing that we identified on our team was some bottlenecks as it related to our build process due to basically environment variables and the delta between development machines and the place that we do standard builds. And that's pretty much the amount of detail that I can go into. But by changing this one bottleneck, we cut our build times in half. And it was a huge time saving. The other thing that I really like is the cost of downtime. This is unique for every organization. If you have a shopping cart, your cost of downtime is going to be a very sensitive topic. And it is something you can measure. It's not 100% precise. The way you measure it is the time from, it's really you're putting a dollar value on your MTTR. And obviously you want it to be as low as possible. Similar to that, and as a part of your incident response process, talking about the amount of unplanned work. So this is the amount of time that your developers have faced when they context switch and have to go from building functionality to supporting incidents in production. It's very expensive. It's a huge opportunity cost, and it's something that you want to reduce over time. So by measuring this, you can know whether you're doing it or not. The other 2 things I like are just basic repo stats, and they're not difficult to obtain. But these repo stats will allow you to, number one, just understand the activity by repo and artifact. In microservices-based applications with tons of services, this is a very important metric to have in your back pocket to understand. You could be going fast in one service area and not another, or you could be moving too quickly where you have a set of service owners that are moving ahead of the rest of the engineering team and actually becoming a bottleneck because of it. And then the other area is aging summaries. How many people, how many of you have repos where you have some rogue and latent branches and repos that could potentially be a risk to your organization, or you simply are just not leveraging. Whoops, looks like I'm almost done. Not quite there. The screen share just changed on me. And so by looking at the aging summary of your repos, you get a good sense of places where you may need to do some house cleaning and avoid future issues. All right, so this is HashiConf or HashiConf. This is Hashi Talks. We need to talk about Hashi. I want to give one example of this coming together, and I'm very excited about an integration that we have with Hashi Vault and Hashi Terraform. And I also want to brag for them on their behalf the fact that those three use cases, monitor, audit, and measure, were naturally a part of building this integration, which is being used by customers to make sure that their Hashi Vault is stable, up and running, and being used properly. So what you see on the screen here are standard sets of metrics that you very easily can pull out of Vault and start to visualize these metrics. You can look at lease time from secrets, the average lease time, who's accessing and trying to generate secrets, who's doing it by policies. You can look at it from an infrastructure level. You can look at it as it relates to the delivery chain itself. It's a very powerful tool in understanding the success and the proper adoption of secrets management in your organization. And when you have a lot of engineering teams, as you're onboarding them to this great way to secure your infrastructure, this is an invaluable tool. So this is actually a tool that is out of the box integration with Splunk, but you can envision doing this with whatever analytics platform you are using. The nice thing about this is, like I said, they've already taken into consideration all the aspects of monitoring and compliance in particular. So please reach out if you have any other questions. I'm going to jump over and see if I can answer any on the chat if there are. Happy to always continue the conversation and point you in directions that might interest you. And please thank everybody who organized this event. It's a lot of work. Technical glitches happen all the time. It's a thing. We all deal with it. And just a tremendous amount of effort to put these together. And I'm very tickled that they invited me to speak with you today. So enjoy the rest of the sessions, enjoy the sessions tomorrow, and hopefully I get a chance to interact with you at some point in person. So thank you.